I think in this session we're going to cover a few different topics, so we'll be a little wide-ranging, but that's okay. So I'm going to be covering this climate change and elevated carbon dioxide effects on global diets, a modeling study, in 10 minutes or less. So you'll have to forgive me for glossing over a few details, but leading up to this was published in 2019. We did a study with RTI and various government institutions and the Harvard School of Public Health, and published in the Lancet, the Lancet Planetary Health. Problem with that report, but the Lancet Planetary Health. So if more details, there's plenty of stuff going on here. We spent quite a bit of time thinking through a lot of these things. And I want you to keep a couple of pictures in your mind just for the next slide, because these didn't fit very well and I like them. But anyway, so thinking about nutrients in plants, especially micronutrients primarily, think about minerals and vitamins. Minerals are being pulled from the ground or the environment around them, whereas the vitamins are being biosynthesized, the plant. And so you have a much more complicated picture on the vitamin side than you do on the mineral side. Although it's also way too simplistic to just picture it this way, because how the plant actually gets those nutrients into what we're eating is also a complicated. That's a little bit. So there were various studies based on these open air carbon enrichment both chambers and out in the field. And then a lot of this stuff was first summarized in some shocking reports from these two researchers, Lolads and Myers, back in 2014. And so they were part of this research team, and we wanted to pull this into what does it mean food system level and not pure nutrient. So when we look at across all crops and all the information out to 2050, we see that carbon dioxide in the atmosphere, as projected out to 2050, depends on how you slice and dice the data, but some people say about 5%. We found, and this is what we report in the article, more about 2 to 4% out to 2050. And so the clear signal is on the minerals, with the vitamins being biosynthesized. There's both pluses and minuses, and the signal is much less clear. So we chose to focus on the minerals because that's an easier signal to deal with. And all these processes in terms of the effect of elevated CO2 on what's being put into the plant is, they did it in a very simple way with the elevated carbon dioxide, but if you combine that elevated carbon dioxide with heat stress, you get a different answer. If you combine it with water stress, there's a bunch of different cross effects that make this important to study moving forward with a more fuller picture. And I think a lot of people they mark this up to dilution. They think that with more CO2, the yields are bumped up a bit. And there's just less nutrients in the grain or in the potato or whatever. It's a little bit of that, but there's a much more complicated mechanism. I guess that's just one thing that one of the myths to dispel. It's not just. So we combine that information with our modeling in the impact model, with our detailed system. More resources here for the reader to explore in deeper detail. But we have a highly detailed model, both breaking down the world into subnational production units, and then we also have a fairly well defined, at least at the country level, what's going on in consumption and reactions to changes in income. That's my shortest presentation of the impact ever. So the overall effect in terms of global availability of these nutrients and combining these things, and if we think about, so the impact model projects things out with assumptions about things that are changing. a more dynamic system. So we're expanding production, and so that's the light blue section here. So nutrients for protein, iron, and zinc in terms of milligrams per grams per person per day. So the greatest expansion is going to happen from this technical expansion. If you consider what the crop models are telling you about CO2 fertilization of yields, you get an additional bump. That's the dark blue part, which is, there's a lot of debate about that, but we don't have to go into that right now. And then the carbon nutrient penalty, the one that we were talking about on the previous slide, where we're seeing minerals particularly being reduced. That's the light red part that's actually reducing that availability out in 2050. And then there's also some changes in crop productivity due to heat stress and precipitation stress and things of that nature, the dark red section. So we end up with about a 14 to 20% reduction in what would be in a world without elevated CO2. And that's where we end up with these dark bars in terms of levels out in 2050 for these different regions. That's a big picture, but and this is too many words, so don't pay attention to it, but this is just for record's sake. But I think what's more interesting to me is what does that mean for a diet that's in a given region. A 20% reduction in availability of iron in barley is important for some regions and some diets. The way I get my barley is through beer, so it's not important to me, but you can see that the different diets are key in terms of how things play out for this type of effect. So we wanted to compare what was this. We can see the change in the availability in the diets that we have projected, and let's compare that to recommended nutrient intakes in the different regions. And so we did quite a bit of work in terms of determining recommended nutrient intakes according to population pyramids and everything in these different regions. And we can make a ratio of availability over the recommended nutrient ratio. And so that gives us, and then we can sum that up over the different types of food items and have a complete picture of what's available compared to what's needed, at least at an average country level. So there's going to be a lot more variability down at subnational levels, obviously, depending on geography and populations. And so we end up with a picture like this. This is, look at the bar chart, thank you, first. And in a world without the nutrient penalty, it's the lighter bar. And so we have, at least for protein, iron, and zinc, we see in terms of availability that's out on the market and what's necessary, we see that a lot of regions are somewhere in the rate, this R&I ratio is somewhere between 2 and 4. So twice the amount is available than what's necessary for the recommended nutrient intake for a given person. Now obviously everybody should be flagging on, but there's population differences and distributional questions and so on and so forth, and absolutely. And so that's something that's a further research question, but at least this shows us what it looks like at the country level. And then we have the darker bar that adds in this climate nutrient penalty, and we see the different reductions in across the different countries. And I guess where I get worried is in South Asia, Sub-Saharan Africa, for iron and zinc. We're at about, the R&I ratio is about 1. So there's no possible way that the most of the population is able to actually access the amount of nutrients that they need on a R&I level. And then the carbon nutrient penalty adds into that stress. And then we can see this happening across the world. We see the barley problem kicking in here in northern Africa, for example, with the zinc, and then other distributions around the world. And I guess the basic summary, everybody can read, regions currently facing challenges are more strongly affected. And that's my stopping point. Thank you.